In this video, I want to have a look at combinations. So a combination, written as NCR, is the number of ways that we can make unordered selections of R objects from N objects. So we've already been looking at permutations, and the important difference between these is that combinations are when order doesn't matter, so we're making unordered selections, whereas permutations, order did matter. So let's have a look at the difference between those two things. Say that we have 10 people in a race. Now, if we want to pick a first, second, and third place winners, we need to find, we've got 10 people and we want to find the number of different ways we can have first, second, and third. So this would be a permutation because order does matter. So to do that, we would write 10p3. So we've got 10 people and we're choosing 3 of them. And that would be equivalent to doing 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. And that would give us 720. So there's 720 possible combinations for people coming first, second, and third out of a total of 10 people. Now I want to change that question slightly. So we're still going to have 10 people, but this time we don't care about first, second, and third place. All we know is that the top 3 people, so the people that come first, second, and third, they're all going to go on to the next level of the competition. So we don't actually care whether they came first, second, or third, as long as they were in that top 3. So what that means is that when we're doing this, we're going to have some redundancies in there. So for example, if we had A, B, C, so that's our first, second, and third place winners, that's the same thing as having A, C, B. It's also the same thing as having B, A, C, B, C, A, C, A, B, and C, B, A. So because those 3 people can be arranged in 3 factorial different ways, because we don't care about what order they're happening, we've got 3 factorial redundancies in there. So instead of doing 10p3, which gives us 10 factorial over 7 factorial, like we figured out down here, we also have to account for the fact that we're going to have double ups or triple ups or whatever it is. So we would have to divide that by 3 factorial to get rid of all of our repetitions. So this now is this over 3 factorial, and this is the definition of our combination instead. So 10c3 would look like this. So let's have a look at the formal definition of that. Oh, sorry, actually, let's figure that out. If we were only caring about the top 3 people, not actually what order they came in, then that would give us 120 possible combinations for top 3s. And the notation we use for that is NCR, like up here. We can also write that though as NR in a big tall set of brackets. So these are 2 different notations that mean the same thing. And the definition of those would be N factorial over N minus R factorial. So that's the same definition so far as a permutation, but then we're also going to divide by R factorial. So this is the definition of a combination. We could also write it as NPR over R factorial as well. So that's how our permutations and combinations are related. Now you can work it out like this using your factorial button, but there is a combinations button on your calculator as well. On a Casio calculator, it's just above the division key, and on a Sharp, it's above the number 5. All right, so let's have a look at a problem. So I'm going to say that I have 15 students, and we want to choose 6 of them to be representatives at something. It doesn't matter what. So I've got 15 students in total, and I want to choose 6 of them. So if it's just a problem straightforward like that, we'd have 15, and we're going to choose 6 of them. So we can pop that in our calculator, and that's going to give us 5,005 possible different combinations of 6 students out of those 15. Now, if I make the question more complicated, I've got 15 students. I still want to pick 6 of them. So it's 16 students, pick 6. But this time, my 15 students, I'm going to tell you how many are boys and how many are girls. So in this next question, I'm going to say there's 6 girls, and that leaves us with 9 boys. And I want to pick it so that I want to pick 3 girls and 3 boys. So that means if I'm going to pick 3 girls out of those 6 girls, I'm going to have 6 and I'm going to choose 3 of them. And then I'm going to have to multiply that by the number of combinations of the boys. So we're going to have 9 boys and we're choosing 3 of them. So we can pop this in our calculator and we would end up this time with 1,680 choices instead. Now the last one I want to have a look at, we're still going to use that there's 15 students and we're picking 6 of them. We're still going to use that there's 6 girls and 9 boys. But this time, instead of saying that I want to pick 3 of each, I want to pick at least 3 girls. So at least 3 girls, that could mean that I could have 3 girls and 3 boys, or I could have 4 girls and 2 boys, or I could have 5 girls and 1 boy, or I could have 6 girls and 0 boys. So I needed at least 3, so these are all the different possible combinations. So for each of these, I need to go through and do a calculation like this. So for this one here, 3 girls, 3 boys, it'll be this calculation that we already had. So we're going to have 6C3 times 9C3. And then we're going to add on this one. So this time I'm going to have 6 girls, I'm going to choose 4 of them. And I'll multiply that by our 9 boys and I'm choosing 2. And I'm going to add on, if we've got 6 girls and we're choosing 5 of them, times 9 boys and we're choosing 1. And then add on that we've got 6 girls and we're choosing all 6 of them, times 9 boys and I'm choosing none of them. And if we pop all of that in our calculator, we'll have 2,275 possible different ways, possible different groups that we could choose of 6 students that include at least 3 girls. So that's having a look at combinations.